Assalamualaikum and a very good morning. I'm Damai Kalisha and I'm joined by my teammates Amber, Daniel, and Zakwan. We are from SMK Wangsa Melawati and today we will be presenting an infographic under the topic Phenomena that occur on the surface of the sun.
Now, let's talk about sun facts. The sun appears as a ball of glowing gases. The sun consists almost entirely of two types of gases, hydrogen and helium. How is helium produced in the sun? At the center of the sun, the temperature and pressure are so great that as hydrogen atoms collide with each other, they stick together or fuse. This reaction is called nuclear fusion. In this process, four atoms of hydrogen combine into one atom of helium.
Let us start with granules and sunspots. What are granules? Granules are small, bright, grain like areas on the sun's surface known as the photosphere. They are formed by convection currents where hot gases rise in the middle and cooler gases sink at the sides. This rising and sinking creates a bubbling effect on the sun. Each granule is huge, about 1,000 kilometers across, but they fade away quickly, lasting around only 20 minutes. How about sunspots? Sunspots are the dark regions seen on the surface of the sun. Sunspots appear dark because the temperature are lower than the surrounding areas, which are made up of granules. Sunspots are the locations of very large eruption in the photosphere. This phenomenon may last more than a week. Other than that, sunspots are phenomenon that always exist in pairs or groups.
The solar cycle is the cycle that the sun's magnetic field goes through every approximately 11 years. Every 11 years or so, the sun's magnetic field completely flips. That means the sun's north and south pole switches places. Then it takes about another 11 years for the sun's north and south pole to flip again. In solar physics, a prominence sometimes referred to as a filament is a large plasma and magnetic field structure extending outward from the sun's surface, often in a loop phase. Prominences are anchored in the sun's surface in the much brighter photosphere and extend outwards into the solar corona.
Next is the solar flares. A solar flare is a sudden flash of brightness observed over the sun's surface or the solar limb, which is interpreted as an energy release of up to 6 times 1025 joules. It may be followed by a coronal mass ejection. The flare ejects clouds of electrons, ions, and atoms through the corona into space. These clouds typically reach Earth a day or two after the event. Similar phenomena in other stars are known as stellar flares. Other than that, solar flares strongly influence space weather near the Earth. They can produce streams of highly energetic particles in the solar wind, known as a solar proton event. These particles can impact the Earth's magnetosphere in the form of a geometric storm and present radiation hazard to spacecraft and astronauts.
Next, coronal mass injection. What is coronal mass injection? Coronal mass injection, or we call CME, is a significant injection of plasma mass from the sun's corona into the heliosphere. CME often like the huge twisted rope, which scientists call flux rope. How do CMEs happen? CMEs happen when the sun's complex magnetic field become overly twisted and stressed. What happens if CME hits the Earth? It can disturb Earth's magnetic field, accelerate energetic particles, and trigger geomagnetic storms. It also causes the beautiful northern and southern aurora light.
Solar wind is a stream of energized, charged particles, primarily electrons and protons, flowing outward the sun through the solar system at a speed of 900 kilometers per hour at a temperature of 100 million degrees. It is made of plasma. The solar wind is caused by the hot solar system, which is the outer layer of the coronal atmosphere.
Now, let's move on to definition of Earth magnetosphere. A magnetosphere is the region around a planet dominated by the planet's magnetic field. Other planets in our solar system have magnetosphere, but Earth has the strongest one of all the rocky planets. If the magnetosphere disappears, Earth will lose its invisible shield against solar winds and cosmic radiation.
Move on, formation of Earth magnetosphere. Earth magnetosphere is formed by the interaction between our planet intrinsic magnetic field generated by churning molten iron in the outer core and the continuous flow of charged particles from the sun's known as solar wind.
Damia, what SDG can relate with our topic? I think SDG 7, affordable and clean energy. The sun provides renewable energy. Learning about solar phenomena helps us use solar power more efficiently for a sustainable future.
Our topic is also related to SDG 13, climate action. Studying the sun helps scientists predict space weather, which can affect satellites, communication system, and power grids, improving preparedness for climate and environmental challenges. Did you know the magnetosphere shields our home planet from solar and cosmic particle radiation, as well as erosion of the atmosphere by the solar wind? Sometimes, gases on the sun's surface erupt, shooting far out into space. These are called solar flares. They can interfere with satellites, meaning our phones and televisions might not work,